Hello and welcome to another C++ tutorial. So what we're going to be looking at this time is the concept of something called functions, which we've actually already used functions a little bit already. We just haven't sort of drawn specific attention to it. So we're going to be taking a look at them in more detail this time. So a function is a way of creating a reusable block of code. So just like how we have things like our loops, like a for loop that allows us to efficiently perform the same operation multiple times, the purpose of a function is largely to do that as well. It allows us to, if there's a common task that we're needing to perform, we can put it into a function. It also allows us to keep our code a bit more manageable, because can imagine a large project, even a moderate-sized project, you can get to thousands, tens of thousands of lines of code. On much larger projects, you're dealing with hundreds of thousands or millions of lines of code even. And if all of that was here inside main, it would be challenging, to say the least, to find anything. Whereas putting things inside of a function, we can firstly reduce the amount of code because we're able to reuse sections of it, and we're also able to make things a lot easier to find. So in terms of what a function is, we've actually already got an example one here. Main is a function. And functions, we're going to create our own one in a moment. So what I'm going to do is I'm going to create a function that what it's going to do is it's just going to greet the user. So I'm going to write it first, and then we'll break down what the different elements are and how it works. Just going to make it display out to the screen. And then I'll write the line of code to what we'd say run or call. You might also hear the terms execute or invoke the function. So run, call, invoke, execute the greet user function. Okay, so that will to do what we're after, but let's break this down. So greet user, this here is a function. Functions have a number of key elements to them. So one of the things that functions must have is a name. In this case, greet user. That name, much like anything else in C++, is case sensitive, so the case does matter. So we want to make sure we pick logical names. We want to keep our function names clear and easy to understand. So functions have a name, and they have the actual body of the function here, which is much like how we can do with loops and if statements. It's defined by these braces, and I could have if statements or loops within that, but this outermost set of braces defines the beginning and end, defines the scope of the function. And then we have the particular content of it. So, okay, those bits are similar to what we've seen in C#, they make sense. But what about this void? This one here is int, this one is void. So functions can give back information, something that's called a process of returning. So the void here, that means that greet user doesn't return anything. So greet user is saying that it doesn't return anything. It actually can't return anything. If we tried to, we would get an error. Whereas this one here, main, is saying that it returns an integer. And that's because that's a common thing that programs can return a particular value, and that value indicates whether things were successful or not. It can be used for indicating error code, stuff like that. Now main is a bit of a special function in that we can get away with not providing the return value here. That's not normally the case. So if I did something where, okay, it was one that can return an integer. And let's say we called it, what is the magic number? Now with this, it's currently fine. If I go and actually set that up, and then I'm going to go and build this, then we can see it actually is giving us an error. So main, we can get away with not returning a value. It'll just return a particular default. But with any of our custom functions, we have to actually return a value, which we can do that by saying return, and then the actual value. So in this case, it will return the value of 1, 2, 3, 4. But if I just did that, well, that value is not going anywhere. So I could have a variable here, returned value, which I then output. So returning a value, if we've said that a function can return something, which in this case we're using an integer, but we're not restricted to it being an integer. You could use any variable type there, is completely valid. So it doesn't have to just be an integer. In this case it is, but it could be any other variable type as well. So we could return a string, we could be even returning things like lists or vectors or maps containing data. That's all entirely valid to actually be doing there. So, okay. Our functions, we know they have a name. We know they have some indication with a return value, either indicating that they don't return anything, or that they return and the particular type they return. And we've seen how we can call or run a function. So, okay, that seems logical so far. And in terms of the order of how things happen, what will happen is we'll be running through here, we'll get to greet user, it'll see this, and then it'll say, okay, I'm trying to run this greet user function, it's up here. So it then will run, transfers where it's currently running up to here, it'll run this line, and then when it gets to the end of the function, it will then go and return back to here, and then keep running with the next one. When it gets to this line, what happens is it runs this function first. That function, what value comes back there, effectively, this function gets replaced with that value. That's what we sort of see effectively happen, which then means it will store that value into the variable that we've set up here. So, okay, we can run a function, we can get there and get a value out of it. What if we wanted to provide information into a function? And that's something that we can do. So we can give a function something called parameters or arguments. Now I'm going to set up one here. And what I'm going to do is this. So it can say hello and the name. Now, the way that we are providing this parameter here, there are some slight adjustments that we can make to that. That is actually something that we will be looking at in the next video, where we're looking at different ways of passing information around. So I'm going to use this current approach for passing it in, just because it is simpler in terms of the syntax, but we will look at improvements for it. This is not the ideal way of passing in things like of a string, so this is just a temporary method. So, okay, we've given it a parameter, and we can see there's actually an error here. So if we provide a parameter, then when we go to run that function, unless we provide that parameter here at the point we run it, it's going to not compile our code. So, okay. We're going to have a name that is clearly indicating that we need to fill stuff in. We could be prompting things, stuff like that. But we have to provide the parameter. Now, the order here matters because we could have multiple parameters. So that's something that is supported. We could have other parameters, and the order matters. So I'm going to just run this so we can see what happens. So we can see outputs the values, which is good. So when we do that, whatever we put here gets put into this parameter. And this name here, so the name we're using for this variable, only has meaning within this function. So I could use literally any bit of text here. It would be a terrible variable name, but that would be entirely valid as a variable name, and none of the code outside of that function cares what the variable name is because it can't see it. If you remember back to when we were talking about scope, because everything here for the function is within this separate scope, nothing else can see that name. Not another function, not our main function, none of the things are able to actually see it. So these names here only have meaning within the function, and we want to make sure those names are clear and are logical. That's always really important. So, okay, we can pass in a single parameter. If we wanted to pass in another parameter, what would that look like? So let's say we pass in a float, for example, percentage. So we could say then the percentage is, we output the value like that. And again, this is giving us an error because we haven't provided that parameter. So I could provide the value and that would work. It'll display the name, then it'll display the percentage value. And it follows the same process that happens. So the parameters here get substituted in order. So that works well. But we can hit cases where we might not want to pass in all of the data, or where we might want to have different things that we pass in. So for example, maybe I want to have something where I just provide the name. So I've got two ways of doing that. One option is I can do this. Name. And I can just transfer this over. So then that will allow me to do this. So we can have multiple functions that have the same name, providing what's called their signature is different. So the signature for a function is the name and the type of the parameters that are provided to it and the order that they occur in. So if we have string then name, so a string then a float, that is a different signature to something that was float then string. The actual parameter name doesn't matter. That's irrelevant for it. What matters is this name and the order and type of these parameters. So as long as that is different, the functions are considered to be different, and our code can actually track down the correct one. So that's one way. This is what's called function overloading. So C# supports this as well, and follows the same sort of rules there for it. So, okay, that's one approach. The other approach that we've got is we can provide a default value. So how that would look is I would do something like this. So we can provide a default like that. And then I would be able to comment this out. And that will still work. The difference will be, so the difference we get between this is in one case, it's going to run both of these lines, whereas in this other case, it just runs the first one. So we'll see the one we get -1 and the other we get the 0.5. So providing default values can be very handy, but it does mean that we need to design our code around that being able to work. So one limitation with that is when we are sort of calling a function with default parameters, we say we're wanting to have the 5th parameter be the default value, but we want to give a specific value for the 6th. We can't actually do that. We would have to provide a value for the 5th and the 6th. So it'll use defaults, but only for the ones after the last parameter that you've specified. For everything up to and including the parameter you're choosing to specify, you have to give actual values there for it. So you can't drop out ones in the middle. You can only drop out ones off the end of a function call. So, okay, we can give our functions names, we can pass information in, we can get information out. What about in terms of where we place these functions? Because we've put them up the top here, and in C# we don't need to be particularly careful about where we place the functions. Let's check with C++ what happens. So I've moved these down here, and we'll go and we will build our code, and we can see it won't work. So whereas with C#, the location of your functions, the order of them doesn't matter, actually does in C++. So then we need to figure out, we often need a way around this, and we do have one. And this is a concept that we don't ever see in C# because it doesn't need it, but we do need it in C++. We create something called a function prototype. So what a function prototype is we take that first line, so that declaration line for the function. I'm going to do that for each of these ones. Oops. So each of these ones, we're going to add that in. And then what I do is I just put a semicolon. And then these prototypes go up to the top here. So these are our function prototypes. And what we'll find if we build the code now is it will build happily. So what these prototypes do is they say, hey, a function is going to exist. Here is the name of it. Here is the parameters that that function will take. And so then any of the code afterwards is able to actually see that. But this is only telling us that that function will exist. It's providing essentially declaring sort of the contract, if anything, of here's what it's going to be called, here's what information it takes in, here's what information it gives back out. So it's defining that, but it doesn't say what the actual content of it is. We have to provide that later on. So these are our prototypes, and then these are actual content, the body of our functions. Now, what if I have a prototype for a function that doesn't exist? This doesn't exist like that, and then we go to build our code. So, okay, that builds. We do get a bit of a warning. What if I tried to run it? Because I can run it. That's valid. But now what will happen? And we can see we get this unresolved external. So if you see something like an unresolved external, that means that you're telling it to use a particular thing. It could be a function, could be a variable, and it doesn't know what that is. It knows that the name of it is a thing, but it doesn't know where that specific implementation of it is. And so you'll get that unresolved external, which that could mean, as in this case, we don't have an actual implementation for it, or it could mean that there are missing files that we need to bundle in. So it could be either meaning there. So, okay, we can create prototypes. We can see what goes wrong if we have something missing there with the prototypes. And we've seen how scope works. Let's have a little bit more of a look with a return value here, because I'm returning here at the end, but I could actually do a prompt here, cin to input value, and I'm going to default input value to -1. And we'll just say enter a number from 1 to 10. So we're giving them a prompt, we're receiving the input. Then I want to just check if the input value is less than 10, then I want to return that value. So now I've got a case where, okay, if it was invalid, I return 1, 2, 3, 4. Otherwise, I want to return the actual value. So I can just do a return input value. So we can have multiple returns in the one function. And what will happen is the first return that gets executed in a function will immediately exit the function at that point. So the function would not try and run any code beyond this point. So we can actually use that often for doing something called early outs. So whereas in a function we could, similar to in a for loop, if you're needing to check a lot of conditions, you could have a lot of if statements and they could get very nested. So rather than them becoming very nested, what you can often do is flip the conditions that you would be checking and return or break or continue if you're in a loop, but in a function doing a return, and then you exit out early. So it avoids getting a lot of nested if statements, which can keep the code a lot cleaner. So return can happen from any point in time. We can also use a return in a void function. So just because it can't return a value doesn't mean we can't use return to early out. So at any point here, I could do return and then a semicolon, and then that will cause it to exit. And at the moment, this code here would actually not run. So if I run this, I won't see the percentage related message, because this is earlying out. So a void function we can return from, we just don't provide any value. So we can have multiple returns in a function. We can use those for exiting at an earlier point to keep our code neater and cleaner, which can be really handy. So a big thing then is, how do we decide when to use functions? How do we decide what goes in a function? How do we decide to split things up? And that's a really important thing. So view functions as a way of, in part, grouping and organizing code. If you find that there is something that you are doing frequently, so for example, you might have something that takes a vector and calculates the average and maybe the standard deviation, a few other parameters. You might be doing that in a lot of different places. So you could write a function that does it. That way then you write the code once and you use it in multiple places. So if you find a bug, You only need to fix it in one place, not in 5, 10, 15 places. So a function will allow us to have reusability there. So anytime you encounter something where you're using that block of logic multiple times, a function is definitely something to consider there, because if it will remove that repetition, that's always a good thing. Less code, always better, because less code, less chance of problems, and also easier to find things. So that's one of the most common cases where you have something that's a thing you're regularly using. A function is good for that. The other scenario is splitting up something. So it might not be a thing that you're needing to run it in lots of different locations. You might only run it from one location, but it might get quite complex. For example, if we take something like the update logic for a character, there's multiple things that could be happening there from the rendering side, from the game logic side, just in terms of positioning and looking around. There's physics side of things. There might be audio. There might be artificial intelligence. We don't want all of that inside the one function just because we don't have any duplication there. We want to split those up into multiple sections so we can have, okay, do the rendering logic, do the gameplay positioning, rotation logic, do physics, do AI. So we can split things up in cases like of that, where something is becoming more complex and more unwieldy. What I would generally try and do, and this isn't always possible, but generally trying to keep it so that no function is much more than a couple of screens worth. I'm using a larger font here, so I would say on this sort of size of one, it would be a few screens worth, but probably around sort of that 7,500 lines of code as a rough ballpark. Once things are getting larger than that, I would generally split those into functions, even if you're just calling it from the one place. And that might mean your update function, say for your character, ends up being, you have update, and then it has update graphics, update physics, update movement, update AI. So it just might be your update function becomes 5, 10 lines. It's just calling these other functions. That's good, because then you can control the order that things are happening in easily. You could switch off particular ones, which can be really handy. So it gives you a lot more control and keeps things more organized. So we use functions when we're trying to create reusable tools, and we also use functions to organize and keep our code manageable and to keep it easy to navigate, to work out what's actually happening with it. So those are the two main cases where I'd be recommending making use of them. So just to recap, we set up a couple of functions, and we looked at how with functions we can provide parameters to them, so we can provide information in, and we can do that in a variety of different ways. And that information that comes in gets provided a particular type, which we have to indicate. So every parameter has to have a type, and we indicate the variable name that only has meaning within that function. So we can set up that it will come in with that variable name. That name has no meaning outside of here, only matters within the function. We saw that we can create multiple functions with the same name, providing their signature is different, where the signature is that combination of their name and the type and order of each parameter. That forms that signature. We also saw how a function can return a value by indicating a particular type. We used int, but we could be using any particular type we wanted here. And it can return it by saying return and then providing the value, which might be directly written in the case of an integer or a string or a float at times. But we can also have it be returning a value from a particular variable. And we saw that we can return at any point. So we can use that to avoid having lots of nested if statements, which can become more challenging to actually navigate. And we also saw void functions, even though a void one doesn't have to return and actually can't return, we can still use a return function, return call within it as a way to exit out early if we need to. So dive on in and experiment with this. See the kinds of things that you can set up. Have a go at creating a couple of functions yourself, in particular functions that are working with different variable types. You could also have a bit of a look at creating it so that a function is calling another function. Experiment with functions having default parameters and see the kinds of things that you can be setting up and creating there. So just dive on in and experiment. You're not going to be able to break anything with it. And if you do break anything, that's a good opportunity to investigate and figure out how it broke and how to fix it, because things are going to break inevitably as part of programming. It's kind of one of the things, compile errors, running into bugs, those are never going to not happen. So running into them is a great opportunity. It's a chance to learn how to actually fix them. So if you do run into errors, good. That's actually handy. Use that as an opportunity to start building some of that learning there, which can be really valuable. Thanks, folks. Hope you found the video interesting and helpful. If you have, chuck in a like and subscribe. It really helps out. It's really appreciated. If you are looking for the code for the project, the code is available up on GitHub, and the link to that's in the description below. As with any of the projects, that code can be used in any of your own commercial or non-commercial ones. If you are looking to try and find videos and other topics, I do have a searchable video archive, which I've placed a link to that in the description as well. If you've got any questions, chuck in a comment below. And if you're looking for other ways to support the channel, then I do have a Patreon, and there's a link to that in the description also. But until next time, bye.